And yeah, this next item just talks about the format of the session. So first of all, welcome everyone. Thank you for coming to the Science and Sustainability session on Earth Day 2024. It's so nice to be at ABRF for Earth Day this year, so thank you for being here. Just a little bit about the outline of how this session will go today. So we do have a sponsored talk. Melissa will be speaking in a minute here. And then after Melissa speaks, then I will be giving a presentation, and I'm trying to keep it to like a half hour, I think. I don't know, we'll see. I did look at it, but I didn't capture the time very well when I was practicing it. And then at the end, we'll have a Q&A panel for the latter part of the session, and there will be 3 of us on the panel here, and I'll be introducing Joe and Sheena later. But I just wanted to say, the idea behind the panel is that I'm here as Sustainability Green Labs, and Sheena and Joe are both long-term members of ABRF, very involved, and they are also 2 individuals that have really been thinking about the intersection between sustainability and shared research resources. So I think together we'll make a great panel to be answering questions from both a sustainability and shared research resource perspective. So with that, I'm going to introduce Melissa here. If I can get my phone to work right. No. Let me try again. Oh, there we go. Okay, now I got it. So Melissa Netwall is a field application scientist with SPT Lab Tech, and she will be giving us a quick overview of their true positive displacement technology, which includes a reduction of plastic consumption. So please welcome Melissa. Thank you. Thank you for being here.
All right, let me switch this over. Hi, everyone. Hi. Does anyone else's feet hurt? I really missed an opportunity with getting the My Feet Hurt little badge yesterday. I think I was in denial that my feet hurt, so I didn't grab it, and I'm really regretting it today. All right. If you have it.
Well, the new game is people just been putting them on.
All right. So, hi. Like Kathy said, my name is Melissa Netwall. I'm a field application scientist with SPT Lab Tech. And as part of our vendor sponsorship, we were able to crash one of the sessions, and I jumped at the opportunity to crash this one. As a bench scientist, and I'll probably touch on this again later, I think everyone in here has probably had a lot of feelings about the number of tip boxes that they throw out at the end of the day. And so one of the ways that I kind of quell my thirst to go back to the bench and stay in this role is by being able to help scientists automate their workflows utilizing our true positive displacement technology. So with that, thank you in advance for your time. I promise this will be quick. It won't be too pitchy, but I think we have some really cool things up and coming with SPT Lab Tech. All right, so the video that you're seeing is from our Dragonfly. It is a non-contact, true positive displacement dispensing platform. We have this integrated into our Firefly as well. It's liquid class agnostic. The dispense volume range is rather dynamic with 200 nanoliters up to 4 mils, which is the entire capacity of the syringe. You can multi-aspirate and multi-dispense, so it's really great for enzyme kinetics assays as well. And we have flexible reservoir types. I'm not going to get into the weeds of those, but if you're curious, stop by and see me, and I can talk a little bit more about those. So in order to give you a better idea of what types of plastic savings you can incur from implementing this type of technology in your workflows, I'm going to start with a really simple example. So this is just PCR setup for one plate. Typically you need 3 different things. You need your master mix, template, and primers. And typically, unless you have a swanky acoustic liquid handler in your lab space, you can only really get away with using a single set of tips for your master mix edition. And so I'm going to quickly go over the consumables that we utilize for the Firefly. So on the top right here, we have SPT. I don't know if you can actually see my mouse. You could not see my mouse. All right, where's this little guy? There we go, all right. So up on the top here, we have SPT, true positive displacement. That's the Firefly and Dragonfly again. Our standard reservoir, we also have a couple different types, but I'm gonna stick with this one. The standard and the low dead volume weigh approximately the same, which is about 2 grams, and they're made of polypropylene. And then the syringe type is made of polypropylene and high-density polyethylene, and that total weight of those two combined is about 4 grams. And I'm just going to compare this to a typical standard air displacement setup that you might see if you're using a larger automation platform. So I'm going to go with everyone's favorite low-profile SBS footprint 96-well diamond bottom reservoir. And that is made of polypropylene and typically weighs, depending on the brand that you're utilizing, about 23 grams. And for the tips that you're going to be utilizing, the way that I calculated this here is an array of 96. And I calculated in just the tip weight itself. I did not factor the tip box weight in this calculation. So it's about 154 grams per set of tips to add your master mix to your plate. Does that all make sense? Cool. So this is just looking at a single plate. Like we just went through, we all like graphs more than we like tables, so I thought I would put it into a single plate format. As you can see, the reduction in plastic consumption is pretty significant. And then if you expand this across a year of running 8 plates a week in 2 sets, so 4 or 2 boluses of 4 plates, over the course of an entire year, so 52 weeks, you can see that you are generating significantly less plastic waste with the Dragonfly or Firefly setup than you would be with the traditional air displacement liquid handling platform. And then another thing that I want to pitch in there, because all of our reagents also come in plastic, is the amount of dead volume that you're also saving with our reservoirs. So the standard reservoir has a 10 mil capacity with a 240 microliter dead volume, 200 of which is fully recoverable. And then we have a low dead volume reservoir, which has a 1.5, but you can push it up to 2 mils, capacity with a 75 microliter dead volume, 35 of which you can recover. So you have a 10x reduction in the amount of dead volume that you're utilizing in order to process those 8 plates and 2 boluses over the course of a year. Like I said, the true positive displacement technology reduces plastic waste, but is also available in 2 of our different platforms, the Dragonfly and the Firefly. And I just wanted to call out, we work quite a bit with a lot of the vendors in the space. So Watchmaker for one, Scale Biosciences, NEB, Roche, we're a pretty kit agnostic, application agnostic platform. And so if you would like to learn more, please stop by and see Netta and I. We're at booth 214, and that is all I have. Any questions, thoughts, feelings? Yeah?
The environmental savings is great. What about potential financial savings?
So, in the dead volume alone, significant, 10x. In the plastic consumption, so the syringes themselves range between $8 and $12 a syringe. And so a tip box is typically, for an automation platform anyway, is like between 20 and 60, depending on the tip type. So you're also saving money, but I thought I would focus on the plastic for today.
That's great. Thank you.
Yeah, of course. All right. I will turn it back over to Kathy if there are no other questions. Thank you. All right. And you're presenting, not a problem. Oh, no.
It's not wanting to present.
There you go.
Oh, there we go. Okay.
Okay, so I have the pleasure of introducing Kathy Ann Ramirez. Kathy has a Ph.D. in chemistry and 15 years of lab experience. Since 2009, she has managed the University of Colorado, Boulder, Green Labs program. She's board member for the International Institute for Sustainable Laboratories, I2SL, and chair of the I2SL University Alliance Group, which partners on green lab efforts and works together to drive changes in systems that will benefit environmental sustainability at research institutions, including the need to connect efficiency and sustainability expectations to U.S. research funding. So we look forward to hearing Kathy's presentation, and then we will have QA afterwards.
Yeah, here again is the agenda. So I'm going to be presenting, and then we'll have a Q&A panel. Hopefully they're about the same length and time. So, oh yeah, the title of my talk today is Science and Sustainability, Green Lab Actions for Impact, and the Important Role of Researchers and Shared Research Resources. And I just want to say again, I'm very thankful to be here today. I love coming to ABRF. This is my third in person. I did do the pandemic virtual. So, and the ABRF community is so engaged on sustainability. And I can tell you that I'm already feeling it so much more since the last time I was here. I mean, the engagement on sustainability has just grown since the last time I came in person, for sure. I can feel that. Even the vendors, when I've been going around, they're all so engaged, just like Melissa is here. I've just very warm receptions. They're like, oh yeah, we want to do more at our company. And I did walk the room. Maybe it was the first time I came to ABRF or the second time, and I didn't get as much as I'm getting this time. So I just want to say, I think we're migrating there and things are changing, and that's nice to share on Earth Day. So, okay, well, I'm gonna get to my talk here then. So climate action plans. Does your university or your company or if you're federal campus have a climate action plan or something similar? You raise your hand if you are aware. Okay.
Over 10 years old count?
Yes. Yes. Well, ours was too, Julie, right? And we're only, yeah, we're only just updating it now. And I think the one that, for example, I have on here, University of Minnesota, I think that's an updated version that they just launched last year. I think a lot of universities are coming up with their updated one. So yes, I would say that 10 years ago counts. But anyways, if you were to search on Google and you were to put in University Climate Action Plan, you'll get pages and pages and pages of links to different universities that have climate action plans. It's becoming the norm, is what I'm trying to say, for a university to have a climate action plan. It's where we're all headed. And it's not just universities, as I indicated before. 2021, federal agencies were doing their climate action plans. They renamed it Climate Action and Resilience Plan, so they're called CARPs. And then companies also are making pledges for net zero. The plans might have different names, but in general, these are climate action plans that are being made. Students are expecting and driving action. We, at the University of Colorado of Boulder, I think we feel this more than ever right now. We have just gone through a draft of our climate action plan, and it's my understanding that about half of the comments on the plan were from the students. So talk about being engaged and action, the students. And in our fields, it's these students who will be becoming the next generation of scientists. And again, they're expecting and driving action. I'm actually working with one particular very driven student that's not even on my staff as student staff, that is doing such amazing things to drive in a very polite and professional way change. So the generation that is going to become our next generation of scientists. They are just driving for change. CU Boulder, my university, the University of Colorado Boulder, we periodically do a campus sustainability survey. The last one was in 2023. 90% of students strongly agree or agree that climate change is a concern for their generation. There was also a survey in 2021 of youth 16 to 25 around the world by Lancet Planetary Health. It got into the like CBS News media. It got published there as well as where it was published in the literature. And 59% of youth worldwide are very or extremely worried about climate change. And my office at the University of Colorado Boulder, one of the things that I've heard presented by some of the members of my, some of my colleagues in my office at the Environmental Center is that action is often the best thing. When you're acting on the issue, that helps with this climate anxiety. So, or worry about climate change. I certainly feel that. That's why I left science and did everything I did. It's why my daughter also is so driven. She's 16 to try to make a difference on climate change. She feels like that action helps her. New Green Labs programs, what we're witnessing at universities, are often started by graduate students. They went into science, because they want to make a difference. Actually, I think I have that on my, later slide. But they get there and they see the footprint. That's what happened to me. I got there, I saw the footprint. I'm like, oh my gosh, I came here to make a difference. Look at this footprint. And left and created the Green Labs program at the University of Colorado Boulder. I was a postdoc at the time, but still very much impacted by that. And that's what we're seeing. Like Johns Hopkins University, their Green Labs program. Graduate student there started the Green Labs program. Caltech, graduate student right now, really pushing forward, and is just an amazing leader on Green Labs at Caltech. This is what we're seeing at the different universities most of the time. It's not always, but a lot of times. The students are going to drive us to change. And science's large resource footprint means that we will not be immune to change. We can't be. Our footprint is so large. With all these universities doing these climate action plans, when they look at the resource consumption of science on these research campuses, it's very large, so it needs to be addressed if we're going to reach our goals at our universities. So this is from our CU Boulder 2021 Energy Master Plan. And so the chart there, the circle represents the energy consumption of all of our buildings across the campus. And you can see what the big one is in gold, right? Research. So research, 42% of our building energy consumption, our major laboratory buildings. That's what's included in that part, our major laboratory buildings. And if you look, though, about how much square footage those major laboratory buildings occupy, it's about 22% of campus square footage. So, labs have a disproportionately large resource consumption. And that's not just energy, it's water, chemicals, and as Melissa alluded to when she asked you, and I saw everyone shaking their heads about the pipette, all the plastics, single-use plastics. That's a very common one that comes forward. So researchers, we go into science to make a difference. That's why I went into science. I assume that's why you went into science, was to make a difference in the world. And like I said, I left the bench because I couldn't tell whether my research was hurting more than it was helping from all the consumption. And I had this opportunity to do something about it. So I decided to leave the bench. And it's been my experience working in this role as the Green Labs manager for 15 years that researchers really do care about their footprint. We're all going to need to be part of the solution to get where we need to go. And obviously we can contribute, right? We're the ones designing the experiment, doing the purchasing, so forth. So scientists can obviously contribute to efficiency and sustainability in the way research is conducted. It certainly is also like how our buildings are designed, the mechanical engineering of the building and so forth. But in our education as scientists, it certainly was true for me, sustainability it is not typically part of the education of scientists, but of course that can change. And that's what the Green Labs community is trying to do. We're trying to get it incorporated into our universities, our research universities, and other universities as well. It doesn't have to be just large research universities. And get this into the education of science by what experience you're having as you're going through graduate school. So these are just some pictures of recycling opportunities that we've been able to get in place at the University of Colorado Boulder, the foam coolers. Of course, we shouldn't even be generating at this point. We should be using, I'm sure some of you, right? Has anyone seen those alternative cold shipment packages, right? But we still get tons of this flowing into, and maybe you're experiencing the same thing. I'm trying to write a call to action at the University of Colorado Boulder that the scientists can participate in to say, okay, let's switch over to those alternative options that have already been developed like 5 years ago, so that we're not generating this anymore. Because obviously the polystyrene's around for until after we're dead, right? It lasts forever. But anyways, you can see there we also have metal chemical drums, glass bottle recycling for chemicals, pipette tip boxes. What's not on here is plastic film recycling as well. You know, we work a lot on water efforts. These are very much chemistry related, but we've done projects with autoclaves also on water. And here's some energy projects. And I'm not going into all, I'm just giving a quick sampling of the projects. We could do an entire half-day session on all the different sustainability actions that we can do with different items. So the top one there is for the ultra temperature freezers at -70, and fume hood sash for our variable air volume fume hoods, getting people to lower the sash will save energy on a variable air volume fume hood. Turning off equipment, we don't need it. And like I said, this is just to give a sampling of what the Green Labs community in general is working on at universities where they have a program. And I wanted to say, if you want to talk about your particular lab with me, I welcome it. I would love to sit down with you on your lab. Maybe you use biosafety cabinets, maybe you use some other piece of equipment, or have another question about an idea that you think you could do for sustainability. And I'd love to have that chance. Maybe I know something to suggest, maybe I don't. There's so many things to be aware of. But I just want to invite you. I have a table down by the registration desk, or you could contact me. I have cards here. You could contact me on the platform, and I'd be really happy to sit down with you for your particular lab and see if we can come up with some ideas. So, but I think for this talk, I'm going to keep it more high level in general, because not everyone has each of those pieces of equipment. So, one of the things I wanted to share with you is these different organizations and try to help explain who does what, and the difference between them. Because I think there's a lot of confusion. I sometimes get calls at the University of Colorado Boulder, and people think that I'm my Green Lab. I'm that organization, and I'm not, or I'm a part of it somehow, and I'm not. I do partner with them, but not. It's not the program that I manage is the CU Boulder Green Labs program. And then there's other institutions with Green Labs programs too. So I'm going to go through each of these to give you a little background. And then the next slide, I'm going to tell you about the different efforts that those programs offer, and like how you could utilize those resources or get involved. Maybe those resources that each one of those offer would fit for what you're trying to accomplish. So I2SL is the oldest lab sustainability program. It's a nonprofit, started in the early 1990s, and it was actually first a federal program. Congress, it was recognized by the federal government that the largest energy consuming buildings in their portfolio were the lab buildings. And so there was a charge to say, why don't we do something to address those? So founded by the EPA and Department of Energy, it was called Labs 21, or Labs for the 21st Century at the time. This is the oldest lab sustainability program, at least in the United States, but I think it's international as well. It is an international organization now. At the time, Labs 21, I don't think there was another program. I could be wrong. But anyways, so because of this charge to have more energy efficient buildings, the I2SL, or at the time Labs 21, started with, okay, how can we design and engineer our lab buildings to be more energy efficient? So this has been the strong focus of that organization. As you can imagine, there's significant participation from companies that are providing services and products for renovation, construction of labs, and then people from facilities management, for example, that want to create more energy efficient building. Our planners and so forth are attending those from our universities. When I first went to my first I2SL conference, 2010, so they have an annual in-person conference, but that first conference in 2010, there was one talk at the entire I2SL conference related to green labs. And I wanted to actually tell you, when I say green labs, I'm talking about actions that scientists can take, the lab occupants can take. When we talk about green labs efforts, green labs programs, those are the targets, the scientists. What kind of actions can they take? What kind of programs can we put in place that they can participate in? So there was a small group of us at the time in 2010 that were doing green labs work, that we were just launching programs at our universities. And so we decided, okay, well, let's bring talks, let's build things up. And so now there's also a very strong presence at I2SL on green labs, and so much so that last year we had a track from the pre-conference all the way through the end, and we're going to do the same this year in September when we go to St. Louis at the end of September. So one of the nice things about I2SL is you got this wide range of stakeholders. You do have those people from facilities management. You do have the planners. You have the safety folks. You have the green labs folks that are interacting with the scientists and so forth. So you have this amazing range of people that are touching labs in different ways and making them more sustainable in different ways. I don't think there's any other organization that's like that. And it's really amazing to have that group of people come together to work on this problem. My Green Lab started, it's another nonprofit, started in 2013. It was founded by a neuroscience that was frustrated by the large footprint of science. And so the idea was she really wanted to share Green Lab actions that scientists could take worldwide. And like I said, some of us were already working on what those actions were at our university. So this was really built upon the early adopters of Green Labs, but it was something that we weren't able to do. We were focused on our university campuses and between our universities, but not about getting the word out worldwide. That was amazing. So now there's this nonprofit that's doing that. One of their key things that they're known for is their lab certification. This is a whole suite of actions that can be taken by scientists in the labs for greening your research. So that's what that lab certification is. And they're interacting with different folks, really, more. With companies that sell products to scientists, like equipment, chemicals, and supplies. Whereas I2SL has a large base that's on designing the lab buildings and the ventilation and so forth, Phoenix controls. Okay, and then you have Green Labs programs at universities. So I pitched the idea of creating the Green Labs program at the University of Colorado Boulder in 2009. There were a couple of universities that were ahead of us by a year or two. Around 2007, 2008, Harvard had a program, and it was started by an undergrad, by the way, I want to say. Amazing. Then University of California, Santa Barbara had a really robust lab rats program at the time, which is a Green Labs program. We are focused on engagement of lab researchers across our campuses, but we are very unified in sharing. We share everything with the Green Labs community, and that includes My Green Lab. I mean, anything that we're working on, we're happy to share with I2SL and My Green Lab. We partner heavily with I2SL and My Green Lab. That is our place. So we establish programs across our campuses for participation by our campus researchers, like the pictures I showed you on the last page. And we advocate for best practices for the lab occupants, but also system changes within our university that can get this integrated into systems, make it more part of the onboarding of scientists and so forth. And I'm going to give some examples of that. So I just wanted to give you an idea of some of the efforts of these organizations that you might find helpful in helping you be more sustainable in your research. So I put this in the middle because the Freezer Challenge, for example, is an effort that's a joint effort between I2SL and My Green Lab. They share that effort. A lot of the organization and operation of it is My Green Lab, but the award ceremony is at I2SL, and they're also involved. Million Advocates for Sustainable Science is another one. I'm going to talk more about that later, but that's a joint effort of both organizations. And they both have virtual events, newsletters, and I put their websites there. So you can sign up and be a part. I2SL, the top circle there, the I2SL annual conference. I mean, this is where it's like ABRF, but for lab sustainability. You all are so passionate. It's amazing. I love, like I said, I love coming to this conference. We are so passionate about lab sustainability. It has the same energy as ABRF. And so this is where, yes, the engineers, architects come about designing the laboratory buildings, but then also the Green Labs community. This is where we come together and we see each other. We get our energy for the year to go back and do more promotion of Green Lab efforts on our campuses. The three in the middle there, Smart Labs, Toolkit, Lab Benchmarking Tool, Labs to Zero, these are all building level efforts. They're really important efforts, but these are building level efforts. So I'm not gonna go too much into those, but if you are someone from facilities or you wanna work on how to decarbonize, like the Labs to Zero is about decarbonizing our lab buildings. It's looking at operational energy use and carbon, and also embodied carbon as well. So it's a very important effort. But the one at the bottom, circular economy lab, that might be something that you're more interested in as scientists. Like they had a recent webinar about the foam coolers and how can we get away from using them. They recently had a water savings project, and these were very well attended by researchers and those in the Green Labs field. My Green Lab also has tons of things that I think you would be particularly interested in. I mentioned the certification already. That's their signature. They're working, actually, new version should be coming out soon, which I think will be greatly improved. So if you want to wait a little bit for that. You can engage in their group, the My Green Lab Ambassador group, so they get together periodically to talk about Green Lab's efforts. They also have a series of 6 module-like courses. They're not very long, and they don't cost very much money, but then you can put those on your resume that you are My Green Lab accredited. And the ACT label is actually something that I'm going to work on tomorrow here. I go around, I've heard already that some of the companies on the showcase floor here do have ACT labels out. This is if you have 2 products and they both have ACT labels, you can look at them side by side and make a decision about which one's more environmentally friendly versus the other one. So that's what that is. And so this has been growing a lot, actually. So I'm going to go around and really encourage others to join this. But yeah, this is an exciting thing. And I think E&I also is often here at your conferences, and they're very engaged with My Green Lab on this ACT label, and trying to get that into their work. So, or somehow connected. I shouldn't speak for them, but and then there's, of course, University Green Labs programs. This is actually with I2SL. There's working groups. I lead this one on the left, the University Alliance Group. If you want to join, just let me know. I'll add you to the list. And we meet monthly by Zoom, and we talk about Green Labs efforts. We often talk about grants and how to address that the grant funding is not really encouraging sustainability. There's a lab waste, landfill diversion working group. There's also a couple more, but these are the ones that I thought you'd be interested in. We also have like a group of the University Green Labs programs have gotten together to create a workshop on how to create and grow Green Labs programs. So that's, I put UVA in here. Is Katya here? No? Yeah, but she's part of the core group, right? So I put this one up here because it's a really interesting model. I like their model. They've combined Smart Labs, which is at the building level, with Green Labs. They're working on the two side by side as they're going through each of the buildings. And I just think it's very exciting, their model that they're using. I wanted to ask though, do your university have a Green Labs program? Does anyone know of? Great, raise your hand if you do. And what university is it? UC Berkeley, great. Yes, the UC system, at one time it got into the president level that every single University of California school was going to have some sort of a Green Labs program. Anyone else have a Green Labs program? Well, and I wanted to say, like, some of the most established ones and successful ones right now happen to be a lot in the South, like University of Alabama, Birmingham, University of Georgia. These are very successful programs. Certainly, you mentioned University of California, so the entire UC system there, Harvard, and others as well. And I'm probably missing a bunch of names, but I'll just leave it at that and ask for forgiveness later on. But like the University of Colorado Boulder, where I work, like we have a whole page of free posters that people can just use for their promotion. So if you did start a Green Labs program, or you were very passionate about wanting to do something in the department or the building where you work, you could utilize our posters. We also have a case study on the biochemistry shared cell culture facility that talks about avoided costs and other benefits. This is a very robust, detailed study that might be of interest to you. And then here I put the website for our Green Labs program, but I've tried to make the webpage for the CU Boulder Green Labs program something of use to scientists and others that want to start a Green Labs program, to find resources that can help them. And then, all of our Green Labs programs, we share everything. We're used to people calling and asking us about starting a program. And so that's something as well that's always open. I've spoken to so many, like even NIH has a Green Labs program. So it's not just the universities. Okay, back to shared equipment. So I just love shared equipment in terms of sustainability because it fits all three aspects of sustainability. And you can see this for the environment and economic legs of sustainability very easily. So you can see the three circles that represents the three legs of sustainability. Avoiding equipment duplication has great benefits for efficiency, right? You're not buying more equipment than you need. You're not plugging in more equipment that you need. You are using your space well by not adding more or needing more space to house more equipment than you need. And so it's really easy to see the environment and economic benefits connected to sustainability for just that efficiency from equipment sharing. But the one I want to also point out is you all are providing access to many people to those shared resources. If that shared equipment had been in a lab that was just an individual lab and closed door, first of all, it's hard to know that equipment even exists on the campus. And secondly, it could be hard for researchers to access. So what you're doing with your shared research resources facilities is you are providing inclusive access. So that is on the social side of sustainability. So you really are playing a very important role with providing that inclusive access, which could be for students, like even undergraduate students could have access to that equipment now. Underfunded research labs versus well-funded research lab, everyone has access. You could even get to regional sharing, where you have an underfunded institution versus a well-funded institution. So there are just very strong benefits for equity and inclusivity in what you're doing. So you, regardless of what you call it, you are doing sustainability by just having shared research resources. So we actually are very aligned. Green Labs programs do a lot of promotion of shared research resources, and we might just use different terms, but we are very aligned in terms of shared research resources, in terms of sustainability and what ABRF is doing. Of course, and I'm not going to go into this, but of course, just beyond sustainability, there's so many other benefits to what you're doing. And this is on the Green Labs website, if you want to look at it. We started off with like 9 benefits. And over the years, it kept adding one as someone would make it a suggestion. We've been stable at 17 for a while. So, but anyways, it's so much more than just sustainability, all the benefits that you're bringing to research. Oh, I'm sorry. Okay, but I want to get into some of the bigger picture things. Sustainability integration for larger scale impact in labs. So I mentioned the climate action plans in the beginning. There's also this kind of fear of the financial situation in the future out there. And so integration of sustainability can help with that climate action and also that financial resilience. And I wanted to bring up one thing is like, I'm going to be speaking on Wednesday about the advocacy that I'm doing as a Green Labs manager, and I share that with the Green Labs community across the nation for CORE's shared research resources because it is sustainability, as we just talked about. And I wanted to bring up the example of, and Julie's here, Julie Lang from Anschutz, that at my sister campus, so University of Colorado Boulder, we're in Boulder, down near Denver is the University of Colorado Anschutz. And I've been invited down there multiple times when they were thinking about starting a Green Labs program. But it wasn't until the researchers like Julie and a few others started to say, we want a Green Labs program. Boulder's had a Green Labs program for 15 years almost. We want one at Anschutz. We're also a large research institution. It's when the researchers asked for it all the way to the upper levels of the university. Now, the hiring, I think like probably very soon we'll hear the announcement. Okay, within a month, okay, of who got the job. So it's already been posted, it's already in the process. And so, but I just want to say, your voices are so powerful as researchers. The sustainability folks at Anschutz wanted to do this. I think the facilities folks wanted to do this, but it wasn't until the researchers said, we want this, that they got a Green Labs program. And so I encourage you to encourage your university, if you don't have one, to hire one, because we're huge advocates for you on your campus for shared research resources. Places where I'm helping to advocate are the onboarding and recruitment processes for campus. Every time we get invited to like new graduate student orientations, we present on the fact that we have shared research resources. And we send out welcome letters to new welcome to new faculty, We send out welcome emails to new faculty. And one of the items we put in there is our shared instrumentation network. Make sure you know that we have shared instrumentation. And we're doing this consistently all the time, even recruitment events that we get asked for chemistry, biochemistry, so forth. We're including that. Make sure, one of the things you can do for sustainability is use shared research resources. We also are very vocal about including shared research resources in strategic planning of the University of Colorado Boulder, and I feel like my colleagues at other institutions are doing the same. FACMAN, facilities management standards, facility visioning and renovation. It is like getting in so that our planner now for scientific buildings on campus is thinking about spaces for freezer farms and shared research resources more readily now. So I just really think there's opportunity here. I encourage you to think about, encouraging your university to go after a Green Labs person for this. I wanted to give a little bit more information on increased, what does this say? How much time do we have left? Okay, 4:15. Okay. One other thing that I think we can really do a lot of is increased sharing of mid to lower cost equipment. It's easy to think of shared research resources in terms of that very expensive equipment, but there is just so much untapped potential, in my opinion, for the mid to lower cost equipment. I'm going to talk about that a little bit. And lab space optimization is also very much connected to what you're doing, and I'm going to give a little bit of example of that. So in these lower items, I'm actually going to talk a little bit more about them. Funding process, also expectations for equipment sharing, efficiency, and sustainability. So this is a case study that we did a while back, 2016, we updated in 2018. But we have this shared cell culture facility in biochemistry, and it has 16 research groups sharing. The equipment in the infographic on the left is how much equipment they have for their shared environment. But we worked with the director of that core, and we determined how much equipment they would have needed if they weren't sharing, and it's on the right. I think it's quite obvious that there is a lot of equipment saving and space saving The space saving is the really expensive part. The space saving by sharing that equipment. You can see that that equipment on the right would have taken up far more room if those labs were not sharing. And so we calculate actually a 30% less space need by sharing. But it's also not about, it's also about keeping the equipment always actively being used. When you have individual equipment and individual labs, you can end up with this situation of unnecessary duplication, which of course takes up space. But even worse than this, as the research changes direction and you have that equipment sitting in an individual lab, now you start to have underutilized or unused equipment and turning that very expensive, and remember, energy-intensive space, and it's energy-intensive because of the ventilation requirements, but you're turning that energy-intensive space into now storage space for this equipment waiting to be used. It begins to clutter up the labs, and maybe you've seen this on your campus. Have you all seen this at your campus? Yeah. I had this in the labs where I was working. So, but it wouldn't have mattered if that equipment was in a shared shared research facility anyways, then even if the scientists didn't need it anymore, some other lab might have needed it, they wouldn't be buying it and so forth. It helps with this clutter problem. And so I just want to share, in 2021, the University of Colorado Anschutz, so again, that's our sister campus down in Denver, their med school embarked on a lab cleanup project. They needed space for incoming faculty. They were thinking about building a building. Funding was tight. Also, it would take so much longer than cleaning up the existing space that you have. But basically, the charge came from the dean of the medical school to look at the existing lab space use. They walked 550,000 square feet of laboratory space. There were 2 teams that did it. Each had leadership. So the dean of the School of Medicine was with one group, and then the next in line under him was in charge of the other group. And these 2 teams, they included this composition here, EH&S, facilities, research affairs. They walked this space and looked. And they also made sure that they did not announce when they were going to be walking. So, and they rated on this scale. So 0 to 1 was storage, clutter, vacant. And then 2 to 3 was underutilized still. They did find some very crowded labs that didn't have enough space, and so forth. So basically what happened is they reclaimed 44,000 square feet in the 0-1 category. So that wasn't just underutilized, that was really underutilized space. So it was either unused, full of stuff that didn't need to be there, or it was underutilized, but heavily underutilized. They hadn't, in this process, they didn't address the somewhat underutilized space, is what I'm trying to say. And they still found 44,000 square feet. I think this represents what's true at most well-funded research institutions across the nation. This is not just CU Anschutz. I think what they did is what a lot of us need to do. And there's huge cost avoidance, benefits for sustainability, and so forth. And importantly, I think our shared research resources, if we move more to that model, will help prevent this from happening based upon what I previously said. So they disposed of tons of items. I thought it was interesting, this quote in their award application to I2SL, clutter and antique/unused equipment is a huge problem at the current and the current process for disposal does not work well. So I just want to say, if you looked, I asked, well, how much did it cost? And they did include this in their last I2SL presentation. About $100,000 is what it costs them to do this. A lot of e-waste, paying for e-waste collection and so forth. And then if they had built a new lab building, in a pre-pandemic number that I use, every 1,000 square feet of laboratory space is about $1 million. If you look at the new chemistry building we're building at the University of Colorado Boulder, you would say it's actually double that. So this is very low, but still 44 million versus 100,000. That's quite some cost difference there. And so again, I really think that this is something we could be looking at our research institutions. I'm going to skip this part. And so an important reason why equipment sharing, optimized lab space use, and existence of full-time employed staffed Green Labs programs are not more established, supported at U.S. research institutions is because, does anyone guess what I'm going to say? If you know me, you probably know what I'm going to say. Funding, thank you, Joe. Funding. expectations are lacking in the research funding process. Yes, and it's both in the grant application process, but also the overhead rate calculation process. And of course, for shared research resources, there are like S10 grants, right? And you have the MRIs. But if you look at the percentage of like for example, the S10 grants, if you look at the percentage of funding from NIH, that's a very small portion. There could be so much more done in the other grants, like the R01s, for example, to also promote the use of shared resources. And we're missing out on that. Those grants also are not promoting energy efficient equipment purchases, a lot of the things that we do as Green Labs. So that really could be improved. The U.S. federal overhead rate calculation process also, this is a process that is lacking encouragement for space efficiency and energy and water efficiency. And the space survey that's done as part of this for large research institutions is really important. It's one of the biggest factors in the calculation. And as long as you can show grant dollars connected to the space in the year of the calculation, then that space counts as grant-funded space. But it never says, okay, you have to be using that efficiently. There could be a massive lab with one person in it. So really, our rates are higher if our overhead rate is higher if we use that space inefficiently and we actually can connect grant dollars to that space. So it's unfortunate. So the universities, if they need that overhead dollars, which most say that they all do, we actually, if we're inefficient, we get more money, is what I'm trying to say. Our rate is higher. And so that is certainly not encouraging efficiency. And I just gave you the example from Anschutz. In my opinion, that's why we have the situation we do. It's part of the reason. Funding is a critical driver in setting research culture, and it also tends to reflect the culture that is seen in my opinion, in our startup packages and our offer letter language. There are exceptions, but most of the time our offer letter languages are not doing as well as they could to promote shared research resources and breaking down that ownership culture over space so that we use space better and so forth. So it's just being reflected there as well. This is a whole nother funding opportunity where we could be making changes to promote efficiency and sustainability and shared research resources. I just want to say that European granting bodies are making great strides, so I'm very encouraged by what's going on. Science Foundation Ireland is doing a pilot with my Green Lab certification. DFG, we haven't had any interaction with them from the Green Labs community, at least that I'm connected with, but they already have guiding questions and so forth, and one of the questions is shared research resources, and then there's others as well about energy efficiency, so forth. UKRI, which is the overarching group for the different federal funding bodies over there, they have a goal of, by 2025, to have environmental sustainability across all their financial decisions. They also are coming out with, and I'm waiting for this, the final version of this this environmental sustainability agreement type thing on best practices. That's down there at the bottom. I will say HHS does have a goal in their climate action plan, priority number 3, and it does very much call out shared research resources, develop language across the HHS grant making programs and funding announcements to advance federal and sustainability and climate resilience goals. But it's now 2024 and we're not seeing much action, and kind of disappointed actually. This was very exciting and we're just not seeing much. So what was created by I2SL and My Green Lab that I talked about earlier was the Million Advocates for Sustainable Science. This was created actually in response to someone saying from the federal government that there wasn't much happening and there needed to be some kind of encouragement from outside of the federal government to hopefully encourage action. And so that's why we launched that actually. And it is Earth Day, and I wanted to encourage you to consider signing this. It's a letter issuing a call to action for science funders around the world to encourage sustainability and research. You can sign it anonymously. And as you can see, we do have some organizational signers. So there's individual signers, and then there's some organizational signers. Aishi, you might be aware of. He asked My Green Lab and I2SL. We're looking for that first department or academic institution that's willing to stand out and sign this. We haven't found it yet, so. But I did bring these posters that have already been up at the University of Colorado Boulder. So I brought them to recycle them with you if you want to take one. You could bring one back to your institution. And I'll tell you, by hanging on the wall alone, probably hardly anyone will sign it. But if you point it out, maybe someone else will sign it. So we do have over 1,000 signatures. So I'm going to just move on. I'm going to pass these out, but I'm sorry if I'm short on time. Yeah, okay. So why don't we get to some questions? I was going to read these. Don't read the bios? Okay, let's just come on up here. And yeah, why don't you come on up here, be here at the, I'm going to. Oh, you will? Thank you. So I thought by having Sheena and Joe up here, we can get questions answered from not only sustainability perspective, but also from the ABRF perspective. So I wanted to open it up and welcome you to ask questions. So thank you very much. And it could be related to items in the talk for sure too.
Is it live?
Yes, the microphone is hot.
And don't worry, if you don't have questions, we do.
We're going to quiz you.
Oh, no, actually, there are questions for us to answer for you, but we could go the other way. Oh, great. Oh, we got a question.
I'll ask a question. Maybe a couple questions. I'm from Agilent. So I'm curious, you showed a slide with the styrofoam.
Yes.
No question there's a lot of styrofoam.
Yep.
But my question to all of you would be, if we had to increase our packaging costs by $100 to send you materials because we were no longer going to use inexpensive styrofoam, would you all be willing to pay for that?
100.
Let's just say it was. I don't know how much it would be. I'm just throwing a
I
number
can't
out.
imagine it's going to be $100.
Oh, that new packaging is expensive. Changes to packaging is expensive. So that's just as an idea.
Yeah.
We all get packages from Amazon, right? Everybody orders from Amazon. You all, well, maybe not everybody, but we all get packages, and when we get those packages, there may be one small item in a big box. We've all received those and wonder, why didn't we get a box exactly the size of the package so that we could reduce the shipping costs and things like that? So if companies had to completely change their shipping so that consumers received packages that were exactly the size or very similar to the size, would you be willing to pay for that? Because there's cost to making those changes to a company. It's easy to say, let's just make the packaging better, but making it better means companies have to have different box sizes to send for every different type of package, as opposed to just 2 boxes that they send the small stuff in and the big stuff in, right? So there are costs to doing these things, and the question is, would you as consumers be willing to pay whatever that amount difference is to cover the costs to make that happen? So that's just one question. I'll just throw it out here. We don't need to answer it. I'm just curious, on that. And then the other thing I've been always curious about is plastic seems to be a huge problem. And I don't feel like, and I had to leave in the middle of your talk to take a call. Maybe you talked about it, but pipette tips. You talked about it, right? But think of all the plastic we throw away as scientists. What are we doing to reduce the amount of plastic or somehow recycle some of the plastics from all of the conical tubes, all of the cell culturing, everything that we use in molecular biology? Where does that go, and how do we address that problem? Because I feel like that's even a bigger problem because of the amount that goes out in plastics. So those are my 2 questions.
Do you wanna?
Well, why don't you address the plastics?
The plastics,
Briefly.
yes, okay. One of the things that we're looking at right now, well, we do have, actually our number 5 PP, the pipette tip box recycling that we have, is actually one of our best programs. That's a very valuable plastic. It's in demand. those boxes that we collect go straight down to Denver, get pelletized directly, and go back out in the market and are resold. It's one of our best recycling programs. That's only, though, for number 5 PP. The other recycling, like we do plastic film, number 2 and number 4, that's filler into the plastic lumber that's on your decks. So it's not a good, like, it's better to have a full circle. The tips that you asked about, one thing that we're looking at is polycarbon will accept those tips. So polycarbon is one that, even though they've been used, has a process for really dealing with the contamination and melting it down. So they're, we're looking at them, and I suggest you look at, because they're the only ones that we know of a recycling company, besides like our local, like Boulder EcoCycle. It also looks at circular economy, but they're looking at circular economy, and so their name is Polycarbon, and we're investigating them right now, as an option for expanding our plastic recycling. So, but right now the tips are going to the trash, and autoclaved first if they're hazardous.
Well, I think that's, part of the question is you also have to work with your EH&S office, see what they're going to allow you to do as well. Because our standard, and I'm sure it's the same for all of you, is you have to autoclave it and throw it away. You're not allowed to do anything else with it. So once the EH&S is on board, then you can do things. And I think with respect to, the cost materials, you're 100% correct. Like, if you want to make the change, like, it's going to be expensive, but at some point, you got to make the change, and it's probably going to be more expensive in the future than it is right now. One thing I've always wanted is, a big institution like CU Boulder just to say, like, no, we're not going to accept that stuff anymore.
Correct.
And then the companies have to change. Yeah. And once they've changed, the prices will come back down. From an individual lab standpoint, it's very challenging, and I'm sure purchasing practices at your institutions are very similar, whereas, like, I may find something that costs like $1, and the person going through their purchasing goes like, well, I found the same thing for 95 cents. You're going to buy that one, and they don't even care about what I wanted as the researcher. They always want the cheapest thing. I think CU Boulder has a requirement that it has to be the cheapest thing.
It might be,
Yeah,
I don't know.
it's bullshit, sorry, it's garbage. Sorry,
Well,
yeah.
To your point, Joe, I think you start to think procurement departments really are the place to start with a lot of it, because the companies say it's expensive or whatever, but the procurement departments push back and say, hey, you buy millions of dollars of stuff from us, so you either come to the middle or we'll go somewhere else. That's really what has to happen. At our institution, I know our procurement department is doing things around green labs. I don't think we have an overall strategy, but they have a green freezer program, and you're right, we're told, buy from this vendor, not from this vendor.
so I think it's a really important partnership. I'm glad that you brought the question up. I think that, every university, every institution is different, but I think that we, as institutions, have to start pushing back and saying, we're not going to accept packaging in this form. I know that our European counterparts are so far ahead of us in terms of addressing this, because they have seen, they understand what the impact is. We are so politicized in this country that, you can draw the line and you've got a lobbyist, talking to Congress saying, no, we've got to be able to sell it this way. So, it's up to us individually at our institutions to step up and say, this is not sustainable. Because that is really what's at issue. Every single one of your laboratories, when they start cutting, you have to be able to address what is really going on in your lab, to be able to push back and say, no, we're serving 200, individuals, for this. We look at what our sustainability practices are. So it's up to each of us.
The community of practice with I2SL did have that webinar on expanded polystyrene shipping containers. I caught part of it, but not all of it, and I need to go back and look at it. But I just want to let you know that if you would be interested, there's a recording of it, is what I'm trying to say. So if you want to see, and there were companies, I don't think Agilent was one of the companies that was there, but there were companies speaking from the company perspective on this problem there. So, but these are the type of things that, like the Laboratory Waste Diversion Working Group of I2SL are talking about and working on, are these type of issues. So if these are things that of interest to you, that could be a really interesting group for you to join and be speaking from a scientist. I've been on their calls before, and there's like people working at microscopes while they're like listening into the call. It's kind of really, so you, if you're interested, just let me know.
How many of you run cores? Great. So one of the things I've been thinking about a lot in this partial new role that I have is how to make sure that our institution keeps supporting our cores. And the green initiatives are a fantastic thing that we can actually participate in, but also utilize to our strengths. When you talk about, you know, a lot of things that Kathy referred to, like the space utilization, the cost avoidance, you know, efficient use of instrumentation, we need to figure out creative ways to give that information back to our higher ups to let them know, like, this is the right way of doing it. Putting the stuff in a PI's lab is the wrong way of doing it. Especially as, you know, I'm really nervous for the next 3 or 4 years financially what's going to happen to a lot of our cores. Like I could see university like, well, we need to cut a couple FTEs. These entities we've built are supposed to be cost neutral, and they're not, so we'll cost neutral them by getting rid of them or shrinking them down. You know, so I'm starting to keep track of things in our cores, like how big is the equipment? How much space does that actually going to save the entire institution versus closing the core and then everyone having to go out and buy their own thing? I think saying like, well, they're expertly staffed isn't strong enough anymore. You know, you need to put dollar signs to these things.
Well, grant dollar signs, right?
I think it doesn't matter, just physical dollar signs.
Well, because, but what I'm arguing for is that, you know, in the cores, in terms of accessing advanced technology, even, you know, regular technology, and the expertise saves money for the institution.
Mm-hmm.
But in terms of writing a grant to say that, you know, these are my aims and it's going to be supported by expertise from the cores, that, you know, that actually does have an impact in terms of getting grant dollars at your institution. So that's the other thing the institutions have to understand is, if you want to call it infrastructure, if you want to, whatever you want to call it, is what the cores bring in terms of adding to the sustainability of the institution. So.
I can't remember if I said it when I was talking about Anschutz, but to me, with that project, what they needed to, and I think they are working a bit towards this, is more support of shared resources to not backtrack to having that problem again. Mm-hmm. And I will say that Anschutz also, I've met with the presenters that came to see Boulder and also presented at I2SL. They are working on system changes to not go back to where they were before. They are visiting the labs every year, it said now, and labeling them red, yellow, and green, just to try to work on optimization of the use of space. So it is a continuing project. But as you can imagine, space, you work in science, is a real space optimization. Working on space utilization, efficient space utilization, that is a difficult cultural thing to work on. And so I think also, just like I was saying about Anschutz, Julie here, by the way, raise your hand, Julie, so everyone can see you from Anschutz. Their support of getting a Green Labs person, their voices on that issue were so important for making that happen. I don't think it would have happened otherwise. Same thing with this, you know, raising the issue that the cores help with space utilization. I think it's a really important angle and can help with this issue. Like we could, the Anschutz Lab Clean Out project is something that's very public and can be shared. And then as part of that solution, the cores come in and we can help from having that go back to that way again.
See, I also think part of the challenge we face at our institutions, and I see this within my own core, is the students think that they have to be working all the time and producing just data, even if it's garbage data, right? Because the PI is going to see them, you're not being productive, you're not doing this and that. So they're always pipetting, and they have 18 different cell cultures going, and then they all get contaminated because they don't know what the fuck they're doing, and they screw it all up, and they have to repeat and waste all this stuff. So what I try to do with all my users, and I think is the responsibility for those of us in course, is we have to educate our users to slow down and think about your experiment. Do the right experiment once so you can keep moving forward. I use myself as an example for this, and you can talk to Spencer Short. He was my postdoc advisor. He thought I was slacking off because I did one experiment a week. That's all I did. I made sure every week I got one done completely. That's all I wanted to do. And in the end, he found out that every week I produced a publishable quality figure every single week. Sometimes the experiment failed, but it was all worked up. So every group meeting, I'd have 30 new slides of, here's all the stuff I've been doing. And he got off my case. I ended up publishing a lot more. I did a whole bunch of stuff, but I didn't waste my time. I didn't waste resources. And that has a huge impact on our footprint as well. Like, nothing makes me angrier than watching a lab. They do all this stuff, and then they either lose the data set or they don't remember, so they repeat it and they repeat it, and then the next round of grad students comes in 3 years later, repeats the exact same thing. I'm like, why are we just, would you please just slow down and move forward? So anyway, education is a big thing, and I think education around the environmental impact of them spinning their wheels is the next aspect that I need to get into and could be beneficial for all of us. Students are the worst. I love students, they're great.
I do think it is the research culture, though, about like the startup packages and stuff that needs to change around this so much that cores will benefit from it because with advanced technologies and whatnot, we need to have the cores and the expertise divided up. But just this, it's my space. You just see all in research. No, I want my own. I want my own. I want my own.
And so this goes back to how do we train our scientists and
Right.
the individual contributor versus understanding team science and collaboration. And we do, I've been in this for a long time, I do see changes, but it really starts with NIH and how they fund the research and what researchers think they need to do. So, we're all in this together. And, like at NYU, we centralized so many things. And one of the things that the cores do is they are part of the interview process with all new faculty so that when they come in, they understand what's available to them. So we have cut dramatically the requests for, oh, I need my own microscope, oh, I need this, oh, I need that. So anyway, yeah.
I didn't put this slide in my talk, but the funding structure for research is setting up this interesting dynamic that's hard to address at our universities. The university, the administrators, the university in general, is reliant on the scientists, so you got the university and you got the scientists, to write a grant that's going to pull in that money that also pulls with it the overhead dollars, right? So there's this interesting dynamic then, because if the university doesn't get that flow of money, of overhead dollars continuing to flow in with the grants, how are we going to keep up with all the jobs and the maintenance of the buildings, paying the energy bills, everything? So it's a constant need. The process with the funding is not asking for efficiency, as I briefly explained to you. And if you want to know more about the overhead rate calculation, I'd be happy to sit down with you. But as I briefly explained, we actually get a higher rate and more money when we're inefficient, but you can connect grant dollars with the space. So what's the point in an administrator or sticking their neck out to say, hey, no, you got to give up some space here. I mean, Anschutz was an example that was successful, and there is cost savings to be seen. I think that example shows it. But if we can build a new building, and every single time we build a new building, our rate goes up at CU Boulder. It's paid for. Why risk your job in that position to push on the side that could push back and be unhappy or threaten to go to another university? I really think the scientists' voices, if we could start to get united behind this cultural shift that needs to happen, it would be really helpful. I mean, I would rather see the funding bodies start to address it, but we as researchers in your roles, it can become socially unacceptable to be not utilizing space well. It could. Social pressure is so strong. I'm sure you all have heard the examples of you saw someone throw that aluminum can, not in the recycling, right? They put it in the trash, and you're like, no, that's gotta go. That's social pressure. The same thing. It can become unacceptable to not be using our laboratory space well, because that is energy-intensive space, and it's expensive space, and we need to be utilizing it well for climate action.
You have to stop.
We have to stop?
Yeah, it's done.
Okay. Okay,
Thanks-
okay.
thanks, everybody.
Hey, thank you very much. If you want to talk more, I have a table downstairs. I'd be happy to stay afterwards, but thank you so much for coming and listening and being a part of sustainability in research. Thank you. Bye.
Thank you, Kathy. I didn't mean to start.
Oh, no. It's great. I thought you were agreeing with me.
Nice job. I didn't want to make the impression that as it is in all
No.
sustainability.
You're 100% spot on.
We have all kinds of sustainability efforts that are going on.
Agilent has a lab in our